Hi everyone, and welcome back to our work on congruence and similarity. Today we're thinking again about similarity, and we're looking at enlarging and reducing figures. Okay, so the first thing that you need to know is that similar figures are created by enlarging or reducing figures. Okay, so they're created by enlarging or reducing figures. In other words, if you have a shape, and we discussed this before, but if I have a shape, so say I draw this little triangle here, and I want to make it bigger, it's going to go through an enlargement process, and it gets me to the similar triangle that's bigger. Or I could start off with that triangle, or another one, and I want to get to something smaller, so it will have to go through a reduction to get smaller. Okay, so if we're going from something small to something large, that's called an enlargement. And if we're going from something from the original to something smaller, then that's called a reduction. Okay, now we've talked informally about this thing called the scale factor, and the scale factor is the ratio of sides in similar figures that we multiply by to get the other figure. Okay, so that's kind of really important to think about. The scale factor is the ratio of sides that we multiply by to get to the other figure. Okay, and then there are two kinds of scale factors. Okay, the first is an enlargement factor. An enlargement factor is where the ratio of sides is moving from the smaller figure to the larger figure. Okay, so an enlargement factor is moving from the smaller to the larger figure. Okay, and an enlargement factor has its scale factor always greater than 1. That's how you know it's an enlargement factor. A reduction factor then is the ratio of sides moving from the larger figure to the smaller figure. Okay, so from the larger one to the smaller one, and that scale factor will be always less than 1. Okay, so let's have a look at some examples together. Now, in this first one, it's going to be a bit hard for me to show you this on the screen, but the steps are there, and I'll try and talk you through it, and of course we'll go through it in class. So the question says enlarge quadrilateral, let's call it ABCD instead of PQRS. Okay, so enlarge quadrilateral ABCD using point O as the center of the enlargement and a scale factor of 2. Okay, so to do this question, it's basically, when it's saying it's a scale factor of 2, that means they want us to enlarge it, because it says that here. And in other words, we're going to need to double the length of the sides. But they want us to do that in such a way that O is the point that is the center of the enlargement. So here are the steps. Draw lines from the point O through each vertex. Okay, so you're drawing a line from here through these vertices that are twice this length. So you're going to have to get your ruler out and measure it on your sheet. So say this was 4 centimeters here, this side AD. You get your ruler from O through point A and measure till you get 8 centimeters, and then draw a point there. Okay. From BC, same things. Well, if this was 4, that would have to be 4 too. So from here, you measure 8 centimeters and you put a point. Okay. It says measure the distance from point O to A and multiply this length by the scale factor. Okay, so we're measuring from there to there and then doubling it for the next point, etc. So you do that for all of them, and then at the end you should have the enlargement. Okay, but we'll go through that in more detail in class. So if you tried it and you couldn't do it, that's okay. Alright, question 2 says use a protractor and a ruler to decide whether the following pairs of figures are similar. If they are, find the common ratio. So you need to get your ruler and measure the side of AB and measure the side of XY and write them on. Same with AC and XZ, same with BC and YZ. Okay, see if they have a common ratio, because in this question you need to decide whether these figures are similar. You then need to get your protractor and measure the matching angles. If they are the same, if all 3 matching angles are the same in both triangles, all 3 pairs of matching angles are the same, then these 2 figures are similar. Same with the next question. So I can do a bit of this question with you. Now, first of all, these are rectangles, so we know that their angles are 90, but you can measure them with a protractor if you want. So I'm going to start off by going angle A equals angle P equals angle B equals angle Q equals angle D equals angle S equals angle C equals angle R equals 90 degrees. Okay, and that's by measurement, because you would have measured that with your protractor. The next thing I can say, okay, is that AB over PQ is equal to, well, there's 3 units there, and there's 4 there. So it's equal to 3 over 4, or 3/4. I can also say that BC over QR is the same as, now in BC is 1, 2, 3, 4, 5 units, and Q is 1, 2, 3, 4, 5, 6 units. Okay. Now straight away there, even though all the angles are the same, I can see that these two sides are not in the same ratio. Like 3/4 is not the same as 5/6. Okay, so that would be 4 again, and that would be 3, and that would be 5. But it's the matching sides that need to be in the same ratio. Okay, so this side needs to be in the same ratio as this side, or that over that, and that over that, and that over that. Okay, so you need to decide whether these two figures are similar. And by looking at them, it looks to seem that they are similar. Okay, so I could keep going with this. I could then go that, CD over RS equals to 3/4, and AD over PS equals to 5/6. Okay, so since all the angles are equal and the matching sides are in the same ratio, I can say that therefore ABCD is similar to, that's a special symbol, PQRS. Okay, so that's the sort of thing you need to be writing that down. So you'd need to do that for the first question by measurement. Okay. Question 3, use isometric paper to reduce the following shapes by the factor given. So you can just draw it on here, and it says reduce this by 2. Okay, now if I'm going to reduce this by 2, that means I need to halve it. Okay, so that's 3 there and 2. So instead of having a 3-sided figure, I'm going to have a figure that's 1.5 units. So let's have a look at this. If I use this bit of the paper here, 1.5 units is going to go, oh, actually that's not going to work. You use your ruler. I can't use my ruler, but drawing it on, 1.5 units is going to be about there. Okay, because that 3 is the total. At the moment I've got 3 and I want 1.5, so I'm going to halve that essentially. I had 2 on the width, and I'm going to change that to 1 because I'm reducing it by 2, which means I'm halving this shape. Okay, so with your ruler, yours should look much better than mine, but you should have that. Okay, so make sure you're using your ruler though. This one wants a reduction factor of 4, so I'm going to, times everything by 1/4. Okay, which tells me here with this triangle, all the sides are 4, and if I times everything by 1/4 or divide all the sides by 4, I'm going to get 1. So I'm just going to get a really little triangle that's similar to it. Okay, again, use your ruler for that. Alright, so write a summary of what you learned today and any questions you have, and bring this your booklets with you to class. Today we've learned about reduction factor, enlargement factor, how to decide whether two figures are similar by using a ruler and a protractor, and enlarging from a point. Okay, so make sure you learn what these terms mean. Pause the video again if you need to and copy everything down, and I'll see you soon.